Okay, so in this section, in this video, we're going to talk about special factoring involving difference of two squares. And then in another video, we'll look at the difference of two cubes and the sum of two cubes. But the special factoring is where you have the difference of two squares, the difference of two cubes, and the sum of two cubes. Before we look at the special factoring, let's review multiplying these two binomials. So suppose you had 2x minus 3 times 2x plus 3. Okay, so we're going to multiply this by using the FOIL method. Now, before we go on, notice that the first terms are alike and the second terms are opposite of each other. So this is a negative 3, this is a positive 3. Okay, so when I multiply the first together, 2x times 2x, I get 4x squared. The outer, I get a positive 6x. The inner, I get a negative 6x. And the last, a negative 3 times a positive 3, is a negative 9. And when I combine like terms, a positive 6x and negative 6x is 0, but I'm going to go ahead and put that 0 here just to remind you about something. So 4x squared plus 0x and then minus 9. Now obviously this is the same thing as saying 4x squared minus 9, and we're going to get to that in a little while. But you see this binomial? So this binomial, you see all the problems you've done up to this point was a trinomial. In the previous two sections was a trinomial. Now this is a binomial. So you see that you have an x squared term, you have a constant term, but you don't have the x term, you don't have that middle term. So since there's no middle term, if you want to, you can rewrite it using plus 0x. Okay? All right, so the other thing I need for you to think about is this. Remember in previous courses you talked about perfect squares? All right, so your perfect squares are something like 1, 4, 9, 16, 25, and so on. And we get these by taking the whole numbers 1 and squaring it. 2 squared is 4. 3 squared is 9. 4 squared is 16, and so on. Okay? So 1, 4, 9, 16, 25. The next one would be 36. These are your perfect squares. There are an infinite number of perfect squares. So what I want you to notice is this. You see this 4x squared? I can write this 4x squared as something raised to the second power, just like I did this. 1 raised to the second power, 2 raised to the second power, 3 raised to the second power, and so on. So 4 is a perfect square because I can write it as 2 squared. 9 is a perfect square because I can write it as 3 squared. 16 is a perfect square because I can write it as 4 squared. 25 is a perfect square because I can write it as 5 squared. So 4x squared is a perfect square because I can write it as 2x, because 2x times 2x is 4x squared. Minus, and just think of this as 9, although that constant is negative 9. Just look at the 9 for a moment. 9 is a perfect square because I can write it as 3 squared. So this right here is called, and we're going to spend some time on this right here, that binomial where you have two terms and a subtraction sign between them. That binomial is called the difference, and you can see why it's called difference because of subtraction of, and then these two terms I can write it as something squared. So the difference of two squares. And so what we're going to do in this section is we're going to factor, in this video rather, we're going to factor the difference of two squares. Okay? So what I want you to notice though is that when I factor the difference of two squares, it is very helpful to rewrite each term to rewrite each term as something raised to a power, because once you do that part, if you can do that part, and it's very easy, if you can do that part, then you can factor as two binomials. So notice, see this 2x right here in parentheses? That's your first and first. You see this 3? Those are the last two terms, except you'll have a -3 and a +3. Okay? All right, so there's a formula, and you'll have a formula sheet on this, but there's a formula for the difference of two squares. So it'll look like this. It'll be a squared minus b squared. So you see the difference of something squared, something squared. So I can factor the difference of two squares as two binomials, the sum and difference. So just like we did this, see where we had that 2x here? So you had 2x here, 2x here. So we had that 3, you had a -3 and a +3. So see where I have that a times a, just think of the FOIL method. First times first, a times a is a squared. And then remember, I want my last to be a -b squared. The only way that can happen is if I say a -b and a +b. Because think, a -b times a +b is a -b squared. And remember, this is not a trinomial, it's a binomial. So you see there's no AB term. So that's going to be a 0. So we get, if you check it, we get AB and a -AB. And when I add them up, I get 0 AB. Okay, I get 0 AB. All right, so that's a formula for factoring the difference of two squares. All right, so let's look at this example. Let's go ahead and factor. Well, this is number 1. 25a squared minus 9b squared. So 25a squared minus 9b squared. Okay, just like before, the first thing you always want to do is see if it has a GCF other than 1. So here the GCF is 1. So now if you see you have two terms, so the strategy is to look at this. You have two terms, and there's a subtraction between them. And if you look at the variables, they're both being raised to the second power. So what you want to do is check and see, is this the difference of two squares? All right. So the way to do that, now at some point you'll be able to do this, to factor this quickly. But for right now, what you may want to do is to do it just like we did this. See this little part right here? So take each term, rewrite it. So I'm going to take each term, and I'm going to try and fill in these parentheses. So what times itself twice is 25a squared? Well, 5a times 5a is 25a squared. What times itself twice is 9b squared? Well, 3b times 3b is 9b squared. So this right here is the difference of two squares. So yes, this is the difference of two squares because I took each term and I wrote it as the difference of something squared. And all you do now is write your answer. So you're going to get 5a. See this right here? 5a. So remember 5a squared. So 5a times 5a is 25a squared. And then 3b goes in the last terms. But remember, there's no middle term. There's no middle term. So the AB is not there. So that means that when I factor this, I need to say a plus 3b and a negative 3b. All right? And there's your answer. So the answer is 5a plus 3b times 5a minus 3b. So when you factor the difference of two squares, the first are alike and the second are opposites of each other. Or the last are opposites of each other. Okay? So let's check it though before you go on. 5a times 5a is 25a squared. A positive 3b times a negative 3b is a negative 9b squared. Now check the outer and inner. So the outer is 5a times a negative 3b is a negative 15ab. Positive 3b times a 5a, the inner, is a positive 15ab. And when I add them up, I do get a 0ab. So there's your answer. Okay? So factoring the difference of two squares is not that difficult. It's fairly easy. But remember, just think about this though. Now remember, that's not the answer. Some students seem to think that once they do that, that's the answer. You haven't factored it. You're just, all you did was just rewrite each term as a difference of two squares, as something squared. Now you factor as a sum and difference. Okay, now let's look at another one. Okay, so let's look at this one. That's number 2. Y squared minus 4 ninths. Y squared minus 4 ninths. So notice the GCF is 1. So before you write the answer as two binomials, you may need to rewrite each term as something squared. So see if that's the difference of two squares. So what times itself twice is y squared? Well, the answer is y, because y times y is y squared. What times itself twice is 4 ninths? Well, the answer is 2/3, because 2/3 times 2/3 is 4 ninths. Okay? So this right here is the difference of two squares. So then all I'm going to do is think about the FOIL method. What times what is y squared? Well, it's just going to be this right here. Y times y. And what do you think is going to go in the last terms? Well, it's this 2/3, because 2/3 times 2/3 is 4 ninths. And all we got to do is fill in the signs. Remember, there's no middle term. The middle term is 0, 0, y. So I need one to be a positive, one to be a negative, and you're done. You see, so when you have the difference of two squares, the first are alike and the last are opposites. And so there's your answer. Now, before you go on, it's always a good idea to check. Y times y is y squared. The last 2/3, positive 2/3 times a negative 2/3 is a negative 4 ninths. And all you got to do is check the outer and the inner. The outer is a negative 2/3 y. The inner is a positive 2/3 y. And when I add them up, I do get 0 y. Okay? So there's your answer. All right. Let's look at let's see. All right. Let's do this one. Number 3. You have 36 y cubed minus 25 y. Oops. 36y cubed minus 25y. All right, so again, always look for GCF. There is a GCF here. The GCF here is y. Okay, so always look for GCF. GCF is y. So I can factor out a y. So I get y times 36y squared minus 25 minus 25. All right, so y times 36y squared is 36y cubed. Y times a negative 25 is a negative 25y. Okay, now, just like we did in the previous video, you're going to take this right here, you're going to go off to the side and work with it. So you want to check and see how you have two terms and a subtraction sign between them, and then your variable is squared. So you want to ask yourself, is this the difference of two squares? That's the question. A question mark. Is that the difference of two squares? So at some point you'll be able to quickly come up with the answer, but if you need to, then write in that missing step here. Write in that step. So what times itself twice is 36y squared? So the answer is 6y. What times itself twice is 25? The answer is 5. So is this right here, is 36y squared minus 25 the difference of two squares? Yes, because I wrote each term as something raised to the second power. So now the answer is, you just take the first parentheses, so 6y, first times first. That's not difficult, it's the FOIL method. 6y times 6y is 36y squared, and then I need a 25 at the end. So that's where that 5 comes from. 5 times 5. Notice there's the middle term is 0, 0y. So I need this to be a negative, this to be a positive, or a positive negative, does not matter. And there's your answer. Well, there's the answer for that, excuse me. So 36y squared minus 25 is this. All right, but again, before we go, you just check yourself. 6y times 6y is 36y squared. Negative 5 rather, times a positive 5 is a negative 25. And do the outer and the inner. So the outer is a positive 30y. The inner is a negative 30y. When I add them up, I do get 0y, which is what I wanted. But remember, that's not the answer because you did have a GCF of y. So you need to rewrite it with this y. So the answer is going to be y, the GCF, times these two binomials. 6y minus 5 times 6y plus 5. Okay? So nothing new. You always knew that you had to factor out the GCF first. And this part right here is the same thing as what we did in the previous two examples. Okay, so let's look at this example. Let's see, real quickly. Let's suppose I had okay, so let's suppose I had this. We're gonna do one more. So this will be number 4. We had 9xy squared and then minus 4x. So 9xy squared minus 4x. So again, look for a GCF. The GCF here is x. So we can factor out an x. So I get x times 9y squared minus 4. So x times 9y squared minus 4. You can always check yourself. Use the distributive property. X times 9y is 9xy. X times a negative 4 is a negative 4x. And just like before, you wanna factor this binomial. So I'm going to rewrite it. And notice there are two terms. So think of the strategy. There are two terms of subtraction between them. The variables being squared. So check and see if this is the difference of two squares. That's your question mark. Check and see if that's the difference of two squares. If it is, then that means I can rewrite both terms as something raised to the second power. So what times itself twice is 9y squared? Well, the answer is 3y. What times itself twice is 4? Well, the answer is 2. So this is the difference of two squares. So yes, it is. So then all you do is just factor 9y squared minus 4 as 3y times 3y, because 3y times 3y is 9y squared, and then 2 times 2, because 2 times 2 is 4. But remember though, I'm missing the middle term. The middle term is 0, and remember the last term is negative, so in order to get a negative, one has to be positive, the other one has to be negative. So notice when you have the difference of two squares, the first terms are alike, and the last terms are opposites of each other. Okay, opposites of each other. And so now your answer is going to be the GCF x times these two binomials. So 3y plus 2 times 3y minus 2. Okay? All right, so that's how you factor this into two squares. Now, remember when we looked at this at that first page right here, and we're going to talk about the special factoring, difference of two squares, difference of two cubes, sum of two cubes. You notice that I don't see the sum of two squares. So the question is, can I factor the sum of two squares? That's going to be the question. And so that's going to be the next video. So look at the next video for that one.